Hello friends, this video on Gravitation Part 19 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos from Part 1 to 18 before going ahead with Part 19. Look at problem 1. The problem 1 says, a 400 kg satellite is in a circular orbit of radius 2 RE about the Earth. How much energy is required to transfer it to a circular orbit of radius 4 RE? That means at present the satellite is in a, let us suppose this is Earth and this is the satellite. So at present the satellite is in a circular orbit of radius 2 RE. Now we want this satellite to be transferred to an orbit of radius 4 RE. Something of this sort. So we want the radius to be changed to 4 RE. So what are the how much energy is required to do this change? That means how much energy is required to make it move in an orbit of radius 4 RE. So see, energy in the initial case. In initial case, it is moving in a radius of 2 RE. So in this case, the initial energy would be minus G ME into M divided by 2 into 2 RE, because in this case the radius is 2 RE. In the final scenario, it is moving in an orbit of radius 4 RE. So final total energy would be minus G ME into M divided by 2 into 4 RE, because here the radius itself is 4 RE. Therefore, change in energy delta E would be equal to EF minus EI. So that will be equal to minus GME into M divided by 2 RE. 1 by 4 minus 1 by 2. So we get, this comes out to be minus GME into M divided by 8 RE. I'm sorry, it is plus. So this is the value of the change in energy. That means this much energy is required to transfer the orbit from a radius of 2 RE to a radius of 4 RE. So this would be the energy that is required. So the first part of the question is solved. The second half says, what are the changes in kinetic and potential energies? Now let us solve the first part as well. This we can also write in terms of small g, that is acceleration due to gravity, which comes out to be gm re divided by 8, because g is nothing but equal to gme by re square. Now if you put the value of g as 9.8, m as 400, RE as 6.37 into 10 to the power 6 divided by 8. So you get the value as 3.13 into 10 to the power 9 joules. So this would be the energy that is required to transfer it to a circular orbit of double the initial radius. Now what would be the change in kinetic energy? The change in kinetic energy would be equal to K final minus K initial, which would be nothing but negative of 3.13 into 10 to the power 9 joules, because the change in total energy would be nothing but the change in kinetic energy, because the kinetic energy will get reduced. Right? Because we have already calculated the values of kinetic energy, potential energy and total energy for an orbiting satellite. If you look at that, you will see that the value of energy, total energy and kinetic energy is the same, just that they are opposite in sign. And the value of potential energy is twice the value of kinetic energy. So potential energy is twice of kinetic energy. Kinetic energy is equal to negative of total energy. Right? So if you want, you can go back to the slide where we proved this. So the change in kinetic energy would be this, And what would be the change in potential energy? It would be twice the change in total energy. So that will become minus 6.25 into 10 to the power 9 joules. So this would be the value of change in potential energy, right? So this is how we calculated the values of all the energies. Let us go ahead and look at another numerical. Calculate the height of a geostationary satellite from the surface of the Earth. So it is a very general problem which needs to be solved. So we will see how do we approach for this. Now till now we saw that for any geostationary satellite, the time period is equal to 24 hours. That is 24 into 60 into 60 seconds. That is equal to 86400 seconds. Right? Now we also know that orbital velocity v is given by the total distance travelled, that is the circumference, divided by time period. So 2 pi r divided by time period. So what is r here? R is nothing but the distance of the satellite from the Earth. Let us suppose this is Earth and this is the satellite. So the satellite is moving in this fashion, right? So what is the value of r? This is the circle in which the satellite is moving. So circumference would mean 2 pi r and r would mean radius of the Earth plus the distance of the satellite from the surface of the Earth. That means this r will be equal to re plus h. Correct? Now, since it is moving in a circular path, we will use the same funda. That is, there is a centripetal force which will be acting, which will be equal to mv square divided by r. And that r will be nothing but capital R. Similarly, there would be a force of gravitation between the Earth and the satellite, and that will be g into me into m divided by r square. Now, since it is moving in a stable orbit, therefore, these two forces should balance each other. That is, Fc should be equal to Fg. Therefore, we say mv square by r is equal to gme into m divided by r square. Now, m and m will get cancelled, r and r square will get cancelled. So, from here we get v square is equal to gme divided by r. Now, what will be v? V will be nothing but, from this equation we can say that v is nothing but 2 pi r by t. So, we can write this is 4 pi square r square divided by t square is equal to gme divided by r. Now we can write r cube is equal to g into m t square divided by 4 pi square. We also know that acceleration due to gravity, that is g, is equal to gm divided by re square, right? So we can, instead of gm, we can replace it with small g into re square. So using that, we get r cube is equal to g into re square into t square divided by 4 pi square. Therefore, r is equal to gre square into t square by 4 pi square, this whole to the power 1 by 3. So this would be the value of r, that is the radius of the orbit. Right? Now we know that we'll put the values of g is equal to 9.8 meter per second square. We will put re, that is radius of the earth, as 6.37 into 10 to the power 6 meters. We will put the time period as 86400 seconds. Now putting these values, we find that r is equal to 42147 kilometer. So this is the value of r which we get. Now in the previous slide we already showed that r is nothing but radius of the earth plus height of the satellite from the surface of the earth. So from this we get h is equal to r minus re. So r is the orbital radius which is 42147. Re is radius of the earth which is 6.37 into 10 to the power 3. Now when we calculate this, we get 35777 kilometer. So that means this is the height of the geostationary satellite from the earth. So geostationary satellite is at a height of 35777 kilometer from the surface of the earth. So friends, please make a note that while solving any problems related to gravitation, you just need to remember the proper formulas and you have to put the values. There are not much tricky things involved here. You just need to understand the question properly and then use the correct formula there. Right? Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.